Okay, I might get started. Thank you to those people who have joined. My name's Daniel Wilson. I'm a member of the Fire Protection Industry Board, and I'm here to talk to you today about some alternatives to the scheduled gases. Just some housekeeping before I get started. Please try to make this interactive. We've got at the top of the screen, there's a little hand button. You can raise your hand and ask a question. Please make sure that if you are going to ask a question, you turn the microphone button on at the top as well. Alternatively, you can write any questions in the chat on the right-hand side. So to introduce myself, if you don't know who I am, as I said before, Daniel Wilson. I've been in the suppression industry now for 13 years across various different parts of suppression, working in lots of sort of categories and alternatives, as well as ODS and SGG. So I'm here today to give this presentation. So let me just kick off. Okay, so one of the things that I'm going to go through in the presentation today is the benefits of transitioning. So what do we see as what the benefits of transitioning to non-ODS and non-SGG are? For those who don't know, ODS I'll refer to is ozone depleting substances, and SGG is synthetic greenhouse gas. So we'll go through some of the options that are available and when the key opportunities to transition are. So hopefully we'll relate that back to people who have existing systems and allow them to schedule in times of when they can look at and replace the systems should they so choose. And we'll also at the end go through where to get more information from. So as a starting point, I guess one of the things is we talk about some of the environmental metrics like global warming potential, ozone depleting potential, and quite often we don't tie that back to something that we can relate to in a daily manner. So in terms of one of the key metrics is from a synthetic greenhouse gas perspective is the global warming potential. So what does that actually mean? And so one of the things is I wanted to bring that back to something that people can understand. So if we took a typical size system, for example, of about 250 kilos of HFC 227EA, which is the name of FM200, that would relate to about 805 metric tons of CO2 equivalent. And to give people an idea of what CO2 equivalent is, there's some examples there that tie it back to what we can probably relate a bit more to. So in terms of greenhouse gas emissions, it would be equivalent to 172 passenger vehicles driven for a year. Or in terms of emissions, for example, 4.4 rail cars worth of coal burn. So you can see from that, just in one system, the effects of why we go through this process and why we talk about transitioning to non-SGG becomes an important factor. So the other benefit that we see is that technicians who don't handle any ODS and SGG don't need to have an EAHL. So from a process perspective, from a licensing perspective, there's operational benefits there. So next, if I have a look at an example of a non-ODS, so if we transition to a non-ODS, Halon itself, if I pick Halon 1301, that has an ozone depleting potential of between 10 and 16, depending on the source that we reference. And that's effectively a multiplier for a reference point, which CFC 11 is used. Halon 1301 is also quite a high contribution in terms of global warming potential. So you can see some statistics there. It's over 1,500 metric tons of CO2 equivalent. And the same sort of thing in terms of gas emissions and CO2 emissions. You can see that there's quite a high usage or high emission release in comparison. So again, similar operational benefits. Technicians who handle it, who transition to a non-ODS and SGG, don't need to have an EAHL license. And for anyone who wants to I guess, put in your own amount of kilos of a particular agent, there's some sources there at the bottom where you can do that, and it gives you a lot of other examples that you can relate. So the next thing I want to talk about is the implications of the synthetic greenhouse gas phase down. So what are the implications, and in particular, what do we have there for owners of new systems? So if you're An owner of a new system, I guess one of the key things is understanding the difference between the various systems that are available and the alternatives that are available. And then also as part of that process, consider the licensing and the operational requirements and what reporting requirements you have and how these are managed, and whether they're managed through yourself or your service provider. The next thing would be to understand each of the systems and consider the alternatives before going through and selecting something based on your criteria. So you'd have an evaluation, look at the system overall for the whole life of the system, assess it against any key criteria that you have, and then select the most appropriate option. Implications of the phase down for existing owners. So I guess one of the things is that the HFC phase down is a gradual reduction in the maximum amount of bulk HFCs permitted to be imported. So this doesn't affect existing agent already in the country. The phase down started on the 1st of January 2018, and there is an annual import limit of 8 megatons of CO2 equivalent. The Australian industry has already started from this perspective, and it's a consistent limit with the current use. So the end point, the goal of phase down is to reach an 85% reduction by the end of 2035, and that equates to 1.67 billion tonnes of CO2 equivalent. So for existing system owners, I guess the key message that we want to get out there is that there's no urgency to do anything. You don't need to go out and replace systems that you have immediately because of this. So supply agent will continue. HFCs already within the country are not impacted. But there are a number of points along the life of the system where alternatives can be considered. And one of the things we'll go through in this presentation is where some of those triggers actually arise. So what are some of the options for an existing owner of ODS and SGG systems? In particular, in this case, we're talking about the synthetic greenhouse gas component. So the options are to do nothing, maintain your existing system, continue to use licensed technicians, and there will be an amount of gas within the market that will be able to help you continue to maintain these systems through their service life. Another option would be to decommission the system, but that's something that we'd recommend only after completing a risk assessment and understanding of the implications of doing so well. Or alternatively, we could look at changing the system to a different system. And examples of this, and I'll go through what each of these are in a little bit more detail and pros and cons. There's inert gas, there's non-ODS and non-SGG synthetic gas, there's water mist, there's hybrid water mist and inert gas mist systems, condensed aerosols, and there's oxygen reduction fire prevention systems. So each of these different systems provide an option, and so let's go through and talk about what some of those are. So when we go through and evaluate the options, some of the factors that we consider, and these will be best reached with your service provider or your contacts within the industry, is the cost. So there's cost around hardware, agent, installation, maintenance, and recharge. You also need to consider whether it's the option you pick is safe for occupied spaces. The other thing is whether it's a clean agent. So sometimes we have sensitive equipment. We need to make sure that we're continuing to use a clean agent, and understanding the ramifications of using a non-clean agent is important. The other thing you want to look at is the quantity of agent. Is there a large impact on the number of cylinders? Do you not use cylinders at all? Do you use something different? You also need to consider system recharge and any length of downtime. And particularly, we'll go through that downtime a little bit more in detail later. Storage and space and location of where a new system could be located, and also the specific application. So as an example, an engine room, it may not be essential to have a clean agent, but certainly in a data center where it's of great importance to have a clean agent due to the sensitive equipment, that type of thing also needs. I'll run through each of those different alternatives that I spoke about. So the first, and probably one of the more common ones within Australia, is inert gases. So there's a number of different inert gases that we can utilise for suppression systems. The pros of these are they're naturally occurring gases, they're a clean agent, and they're also suitable for occupied spaces. But the cons, there's potentially a large number of high pressure cylinders that you have, and they can have longer discharge times as well. So typical applications for these types of systems would be where there is more sensitive equipment like data centers, switch room, and archive stores. So another one of the options is another synthetic gas, this one FK5112, or also called Novec 1230. This in particular has good environmental characteristics. It's also a clean agent and can be used in occupied spaces. There is some cost implications in terms of the agent itself, and from an engineering perspective, it doesn't vaporize as easily as some of the HFCs. So there's other considerations around pipe network, nozzle layout, and those types of things. Typical applications for this: data centers, switch rooms, marine engine rooms. So the next one I wanted to talk about was condensed aerosols. So there's a number of pros around using condensed aerosols. They've got good environmental characteristics. They're compact, low cost, and low maintenance. There's no discharge pipe network. Some of the cons, though, are it's not a clean agent. So you want to make sure that that's why we talked about having comparison between clean agent and non-clean agent to make sure that it's suitable for the area that you bring it in. And also, most of the options out there available under condensed aerosols aren't suitable for occupied spaces. So some of the typical applications for this is switch rooms, engine compartments, places that are generally a little bit more dirty or where a clean agent isn't required. The next option to talk about is water mist. So there's pros and there's good environmental characteristics. We're effectively using water that's pressurized to fight the fire. So one of the things around the pros is that room integrity is not as critical as it would be in a gas system, and it is very effective on large flammable fires. Some of the cons, though, is that it's not as effective on small hidden fires, and also that they can potentially be more complex in terms of the system configuration. There's quite a number of different water mist systems out there. So certainly there's some benefits in terms of growing the system into other areas that you wouldn't typically have a special system as well. Typical applications in the land-based and marine and vehicle applications is subfloor voids, engine rooms, and engine compartments. So another one of the systems that's out on the market, and in the scheme of things, it's one of the relatively newer ones, is having a combined water mist and inert gas solution. This has a good environmental profile, and again, the room integrity is not as critical to make sure that it's effective. And what happens is the gas portion of the system actually helps the mist get into the small hidden fires. Some of the cons can be it's more complex, and there can also be a water residue left over. Typical applications are underfloor floor voids and switch rooms. Another system that can be considered is oxygen reduction fire prevention system. This is a different type of system, typically with your suppression system. It's designed as a detection system that goes along with it. The detection system gets triggered and activates a suppression system to extinguish the fire. An oxygen reduction fire prevention system is different in the fact that you're constantly utilising a lower O2 atmosphere to prevent the fire from starting in the first place. So some of the pros is its good environmental characteristics. You don't have high pressure cylinders or high pressure pipework, and you do get that benefit of continuous fire prevention. Some of the cons, though, are that you need to consider any extra safety measures around having a reduced oxygen atmosphere, and also potential ongoing running costs through the life of the system. Typical examples of this would be around cultural artefacts and heritage archive stores. So the next section I wanted to talk about is around some of the examples of when there's a good time to transition to an alternative. So one of the best examples that's common in a lot of the systems is the 10-year leak pressure testing of cylinders. We'll go through each of these examples in a little bit more detail, but that's certainly one of the key ones where we see it as a good opportunity for replacement to alternatives. Other examples that may or may not happen in the life of a system is changes in room use, changes of a hazard, changes in room dimensions or the relocation of a room, and there also might be other things like ownership changes or environmental policy change. So in terms of one of the triggers that we know is going to happen throughout the life of the system, the 10-year pressure test is a good example. So at this point in time, we can actually plan and have a planned changeover or a planned swap to an alternative. And there's already going to be a point of interruption to the system at that point anyway. So as part of this, you'll have a downtime while the cylinders go off to be serviced. Some companies do a swap over, but typically you've got time for servicing cylinders or transport, and then you've got time for downtime for the uninstall of the cylinders or removing the cylinders from the system and then putting in new ones. And there's also the costs associated with the servicing that can also be considered if you were swapping over to a new one, because you have service technicians on site anyway. So maybe some of the other reasons why it's a good example to change. So I said a hazard change, for example. So maybe you've got an existing IT room and you're going to start including UPS or batteries in there. You might look at the change in type or quantity of equipment. It is common that people change the use of a room or change the size of a room to adjust as their businesses grow or contract. There might be changes in the use of the room. There might be a change in the way that the room operates. For example, an air conditioning unit might shut down or it might start up. Or there might be various other equipment that shuts down or start up that weren't included in the initial design that need to be considered. Another example is the risk profile changes. So maybe a backup facility has transitioned to being a critical facility. There might be business cases around getting a better uptime for a particular client. There might be change in service company or refilling availability, and there might be also a change from some type of UF protection, which is the underfloor protection, to maybe protecting the entire room. So in terms of changes of dimensions, what are some of the things that need to be considered? So if we're looking at the room has changed, maybe the volume's changed, maybe there's a standard change, and we recently had a standard change. So not all gases, but for some, there is a change in the concentration. Customers may want to upgrade to the latest standard. There might also be a change in any openings or penetrations. There might be a change in the cylinder location, or there might be a change in the structural integrity of the room. So ongoing maintenance, if something's picked up in the fan test, where there's additional holes, someone's run additional services in or out of a room, that can all add to the change in itself. And examples of change of ownership or policy, there might be a change of environmental policy, for example. There might be a change of ownership. There might be internal risk management standards that want to mitigate a particular risk. There might be other factors, like there might be approvals or new technology that may mean that there's other alternatives that are better suited to that particular risk. So we've looked at what are the things to consider when you're changing to an alternative. Just to dig down a little bit more and highlight some of the attributes, I guess, of a particular system These are the types of things that we actually need to consider if we are going to change. So if we've gone through, we've done our assessment, okay, I'm happy with a trigger. At some point in time, I want to change my system to an alternative. Then what are the things you actually need to consider for a particular risk? So some of those things include the hazard itself, the cylinder location or the pipe network. You need to go through and do a redesign. So if you're changing agent, you need to make sure that design's updated for the alternative that you're transitioning to. You need to consider downtime, and this is that's certainly one of the more important things, particularly if you're trying to plan and you do have a critical facility. You also need to consider the control and alarm portion of the system. How does a change to an alternative now affect your decision or your selection of detectors and how quick they respond? Then we've also got maintenance. How does any change to an alternative affect your maintenance schedule? And then what do you do with your existing system? How do you dispose of it? So first, let's go through what are the things we need to consider for the hazards. So first thing is what's new in the hazard. What alternatives are approved for those new criteria. So we go through and we have a look and say, okay, well, based on this particular risk, these are the alternatives that would be suitable for that particular risk. In terms of the extinguishing mechanism, do we want to have? So let's say you've got a current system of HFC 227EA, that's actually discharges in a very quick time frame in under 10 seconds. If you're going to now change to a different mechanism like an inert, you could potentially blow out to 60 seconds or 120 seconds for a discharge. So there's an additional time it takes to extinguish that fire. So that needs to be considered. Is the hazard you've got an occupied space? If it does, then some of the alternatives are suitable. The amount of agent is different for each alternative, and it's dependent on the hazard. So I guess when you're going through doing your assessment, you can consider several different alternatives at the same time and see which one is most suitable for that. The time of discharge and the speed of suppression I touched on. Also, is it a clean agent? So is the equipment we're protecting sensitive? Does it need to be protected by a clean agent, or is it a dirty environment? Can you go to something that's not? And also the ease of servicing. I want to consider the entire life cycle of what alternative you're looking at. And so is it going to be easy to service? Is it going to be effective to service? And does it meet the rest of your needs? So during a redesign, if we've gone through, we've selected based on our hazard what alternative is suitable, then we need to go through a redesign. When we're going through a redesign, there's a number of things that need to be considered. So we need to do, depending on the system, if it's a hydraulic system, then you need to go through do hydraulic calculations. And then if it's a pre-engineered system, go through and complete all our checks for that. You need to understand the different profile of the nozzles. So if you're changing system, do you have the same coverage area that you had? Maybe you've got different clearance areas that you need to have. So selecting that nozzle location is quite important. You also need to make sure you're updating all the documentation that's relevant for the system and for the companies that are maintaining that moving forward. And there's also considerations that you need to have around installation and commissioning and additional site training for personnel. So in some cases, some of the alternatives are close, and so there may be minimal efforts required. But sometimes you might find that the alternative there's a lot more effort. So it's about weighing them up and working out what's most suitable for your particular system. And then lastly, you need to consider any pressure relief venting. So pressure relief venting changes for each system. You need to go through and consider what that change implication is and whether you need to increase pressure relief venting or add additional pressure relief vents as part of that system change. When you're considering a cylinder location, so you want to look at what the location is and the distance from the hazard. So certainly there's some alternatives like the other synthetic agents that are non-synthetic greenhouse gas, where distance from the hazard is quite important. they need to be located close. Whereas you might have inerts, for example, or something like a water-based system, like water mist, where you can have a lot greater distance between the location of the system and the room that it's or has. The other thing is, in terms of space for cylinders, some alternatives have a lot larger footprint, so you need to consider that. And also manual handling, is there enough room around where you're going to install it for adequate servicing, changing over? Those are the types of things that you consider. And also access for installation, servicing and decommissioning of the whole system. Floor load's another important one that sometimes gets overlooked. And there's an example there to provide a comparison of what the impact of this can actually be. So if we took a typical system of HFC 2270A at the moment and said, okay, for the floor loading of that is 570 kilos, swapping to an equivalent alternative increases that floor loading almost 4 times. So if you're up on the 10th floor of a building or something else, you do need to make sure that the floor load is capable of accommodating any changes that there might be in that floor loading. And then the other thing is, if you change to an alternative that doesn't have any cylinders, maybe you've got a electrical diesel-driven water mist pump, you might have an oxygen reduction fire prevention system. Those things don't have cylinders that they're using, but then you might have other things that you need to consider, like water tanks or other equipment, maybe access to certain requirements around electricity and those types of things. So they're the types of things that you need. So the other thing is you need to consider the control and alarm. I said that the detection method is important, and it's designed in combination with the system when it gets put in. So if you do change to an alternative, you can't just ignore the detection and control system. You do need to consider it and make sure that it is suitable to the alternative that you're looking at putting in. It might be changes to actuation and monitoring. It might be the actuation of an alternative might be quite different. You might have various nitrogen pilots, for example, that you might be activating something else on. So you need to work out what those actuation changes, how they're monitored, and making sure that all flows through to like a maintenance checklist. Are there any additional valves or switches or controls that need to be installed? If they do, how do they go back to the panel? How are they monitored? Is there room in the panel to have these switches and controls brought back? And then do they impact the batteries that are required? Does the control and alarm system meet the current standards? If you're making all these changes, you'd certainly be looking at how old it was and whether you need to bring that up to date as well. And some of the other considerations are around whether we maintain an IP or IEC rating for that particular equipment. So considering the downtime, certainly a very important thing to do. Whenever you do have a changeover to an alternate, there's downtime involved, and I spoke about some of that before. And so then you need to manage the risks with that changeover. What are you going to do to protect your hazard or your facility or risk that is being changed over? So you've got this period of time where the changeover happens. How do you manage that risk? And there's a number of options around that. Do you consider whether the new system has connected or unconnected reserves? That eliminates downtime from an ongoing perspective around servicing because you still have a reserve that's there. Or what about refilling locations? If you've currently got a particular system, you might have a local filling station that you already know. If you change to a new system, where is your local filling station, or do you have to go into state to get those particular systems refilled? And then also considering the different vertical industries and what considerations there are. So, for example, marine might have different considerations to a system that's in the mining industry. But downtime becomes important, and I'll touch on it again briefly. Consider the maintenance. So if you're changing to an alternative, what are the things you need to consider? You might have new requirements. There might be different tables within the standard that you need to adhere to. So the service provider needs to be aware of those things. and whatever other changes you've made. You'll have a change in baseline data. You might have various recommendations on equipment, and what are the whole life costs, what's the ongoing running costs. Some of those systems have a lot higher running costs over the life of the system than others. So all these things are important. And then lastly, once you've actually gone with an alternative, you've gone through this process of designing a new system that can come in and replace a HFC. What the important considerations are around what do you do with that HFC you have? How are you going to decommission the system? You need to make sure that you're using a licensed person for decommissioning. So if you use an alternative, you don't necessarily have to use the AHL licensed person for a new alternative that's not an ODS SGG. But to decommission the existing system, then you do need to use a licensed person. And make sure that that person or this company you're dealing with is also licensed. Have a transport methodology already determined. You don't want to go and decommission a system and you've got no way of shipping the cylinders. You have to make sure that they're stored safely, and there's a number of procedures around that. And then cylinders containing HFC are sent to a licensed company for reclaim, recycling, or destruction. We work with one of them to be able to do that. Other items can be recycled, so you might be able to recycle steel or pipe if it's not really used in the system, brackets, nozzles, signage. Nozzles can be various materials that can be recycled as well. And then review the detection and control system, making sure that it's fit and compliant for whatever it may have. So what are some of the next steps? We've gone through a lot of information there. So some of the next steps is making sure that you understand what options you have and whether that you're looking at changing to an alternative in a new system or an existing system. If you're looking at a new system, then it's probably a lot easier to do. You can look at all the alternatives and assess all those alternatives against your HFC system. Or if you've got an existing system, then as I spoke about, there's a number of things that need to be considered. So if you've got an existing system and you want to transition, my recommendation is certainly that you start planning with your service provider to do that now. So if you plan up front, there's a couple of different types of plans you can have. You can have plans for a transition on a fixed event, for example, the 10-year service is a fixed event, or changes in a room, or dimensions or use are generally planned. So you can have a transition plan during that. But if you have a discharge, then it's an unplanned event. So if you haven't actually come up with a plan and you have a discharge, then you're under a lot of time pressure then to come back and make sure your system risk is protected. Are you really going to try and change to an alternative if you had a discharge, or are you just going to get the system? So if you can have a plan up front with your service provider, then some of those things can all be planned out and you're not having to try and sit there and plan when you're under pressure. And if you're looking at a new system, understand all the various alternatives. There's certainly plenty out there, and there's a lot of options that you can consider rather than utilising HFC for a new system. So I guess in terms of education and engagement, there's a lot of information out there. The Fire Protection Industry Board has produced a number of informations and fact sheets and regular gas bag that comes out with information. So there's a lot of information there that can help. Certainly, there's a great place to get that information is on the FPIB website. The website's up there, and certainly all license holders, everyone else should be familiar with that. There's an alternative fact sheet that's going to go up there with a lot more detail and cover a lot of the options and alternatives that I've just spoken about. And also another source of information is your service or system provider and get advice from them. So that's it for me. Thank you very much for your time. I appreciate it. If anyone has any questions, I'll remind you again, either put up your hand and make sure that the microphone is turned to on, or you can, in the chat section on the right, you can ask a question. Well, if there's no questions, hopefully I've gone through all the information. As I remind you that there's plenty of information on the FPIB website, and look out for the fact sheet when it comes out. Okay, thank you very much.